Have you ever wondered what's inside of a radiation detector? Well, this is what's called a Geiger tube, and it's actually one of the oldest and still very widely used radiation detectors. So how exactly do these tube-like radiation detectors actually detect radiation? It's actually a very simple construction, which consists of this wire in the center here called the anode, and the casing here, which is the cathode. Now, typically you see a protective mylar sheet that goes over this, and that keeps the gas inside and also is protective for the radiation detector. Mylar is a very thin plastic that allows the lower energy radiation to be able to go inside of the detector and be detected. And when you boil it down to its basic components, it's basically just a can with a wire inside of it. In fact, you can make your own radiation detector using a tin can that your corn comes in and some other household components. Also, a transistor, resistor, and multimeter. If that's something you want to see me make, go ahead and leave me a comment letting me know, and I'll make a long form video showing step by step how to make your own ionization radiation detector. So a Geiger tube like this is part of a class of radiation detectors called gas-filled radiation detectors, and they were the original radiation detectors out there. This one's the Geiger-Müller. There's also the ionization chamber and the proportional counter. They all operate under the same basic principles, just at different voltages. If there's one thing that you take away from how radiation detectors work, it's simply counting electrons, and that applies for any type of radiation detector out there, and gas-filled detectors are no exception. This here is a very simple diagram for how a gas-filled detector works. Again, a gas-filled detector is very simple, and here you can see that anode that I talked about, and a electrical current measuring device, and the cathode here. And this voltage source right here can be something like a battery, applies a voltage difference across this anode and cathode. And that's very important to basically create this capacitor between the anode and cathode. Now, this anode, being positively charged, wants to attract negatively charged things such as electrons. And the cathode, it wants to attract positively charged things such as positively charged ion. In between this anode and cathode is some sort of gas, and a lot of detectors it's simply just regular air. Now, ionizing radiation, which we're trying to detect with these types of radiation detectors, has enough energy in it to be able to take an atom and its electron and remove that electron from it, which leaves behind what's called an ion. The ion is positively charged and the electron is negatively charged. So when that ionizing radiation comes into a gas-filled detector, it interacts with the atoms in that detector, creating electrons and ions. They both fly towards opposite directions, the electrons toward the anode and the ions towards the cathode. Those electrons are then sent along the anode and measured by the electrical current measuring device. Basically, you're just counting the electrons that are produced. And the number of electrons that are produced there can be proportional to the dose of radiation. And now all you got to do is calibrate this with the source of radiation, and now you have yourself a radiation detector.